So now taking a look at these graphs of piecewise functions, we're going to write the equation for these functions. And so for this first one right here, you can see really a piecewise function that's really just got two different pieces going on right here. So I'm just going to use some colors for each of these different pieces. Just have an arrow there. So if I was to like write an equation for that, it's really basically kind of a line. And so we kind of want to think like a y equals mx plus b sort of a scenario. And so for the y-intercept, it doesn't actually cross the y-axis, but theoretically, I guess we could keep following the line if we determined its slope. So it seems like the slope of this has a rise of 3 for every 2 units of run, so it's going to have a 3/2 slope. So if I go up 3 and over 2, lo and behold, we do see that it crosses through a nice integer coordinate right there. Ends up being actually positive 9. So we get y equals 3/2 x plus 9 is really kind of the equation of that line. Now, the thing about this, though, is that it's not the entire line because it's only going when x is at a -2 and below. So we'll acknowledge that once we get to writing the function, and then let's get some information about the other piece. So here, it looks like it's crossing through through a 4 there for a y-intercept, and then just kind of marking some other key points right here. It looks like it's got a rise of -3 and then a run of 1. So it looks like we've got a -3 slope and a positive 4 y-intercept. So this is basically y equals -3x plus 4. But really it's only happening kind of when x is -2 and then onwards from there. So putting this all together then, if we're to write a piecewise function for this, then we have, first of all, this scenario where 3/2 x plus 9, but then comma, restricted when the x values are at -2 or below. So you got the equal to underneath that less than because of the solid dot there. And then otherwise, it could be -3x plus 4, and then a comma to separate that from the domain restriction of x being greater than -2 strictly, because you've got the open circle. So we want to say that 3/2 x plus 9 or -3x plus 4, either one of those two things are going to be equal to your like y value or your output value. So you could say y, or if you wanted to do like g of x or whatever you want to do, that's fine. And then for one more example of writing an equation for a piecewise function, so taking a look at this first piece at the far left right there, it appears that the slope of this is to be a rise of -2 and a run of 5. So you've got like a -2/5 slope, but then if we keep going down to and over 5, you're going to see that it's not going to have quite a nice integer coordinate. And so if we can't write this directly in slope-intercept form, then we might be able to use like point slope form. So recognizing that if the slope is -2/5, and then choosing a point that's somewhere on that line there, like this point right here is -7, then y minus the y coordinate is equal to the slope times the quantity of x minus the x coordinate. So minus -7 means plus 7. And then if we simplify that, y minus 0 is just 0, and then just using the distributive property, we get -2/5 x, and then minus 14/5. And so there you can see that that -14/5 ends up being that decimal y-intercept that we get right there. Alright, so now we've got the equation for that red condition. We'll acknowledge the domain restriction a little bit later on. So let's go ahead and proceed to this purple little segment right here. So this purple segment, it looks like it has a very nice y-intercept there at -3, and also it just has a nice rise and run of down 1 and over 1. So that means we're going to be dealing with a negative slope and a negative y-intercept, just like that. And then finally, this blue segment right here seems to be following a pattern in which it is going up 5 and over 2. So it looks like it's going to be like a 5/2 slope. And then if we keep going over 2 and down 5, it's going to also kind of have a nice decimal x or y-intercept right there. it is going to be negative 7.5. You could probably kind of logically figure that out because it does land halfway between negative 5 and negative 10. But if you wanted to use point slope form, like you certainly could as well, acknowledging like this is 3, 0, and then you also know the slope is 5/2. So y minus y equals slope times the quantity of x minus 3, and then y minus 0 is just y, so you get 5/2 x, and then that would be minus 15/2. But negative 15/2, or half of negative 15, is negative 7.5. So we'll just leave it in fraction form like that. All right, so now that we know what kind of are the equations that define each of those pieces, then we'll kind of finish off writing our piecewise function. So I don't know, I'll call it f of x, how about? It's going to be equal to, so it's going to be equal to negative 2/5 x minus 14/5, comma, and we'll come back for the domain restriction, or negative x minus 3, comma, and 5/2 x minus 15/2, comma. So for that first piece, it turns out that it's only occurring for negative x values that are at negative 2 and below, and because it's got an open circle, it's just going to be strictly when x values are completely below negative 2 there. And then for that middle section that we had in the purple, it's going between negative 2 there and positive 1. So it's going to include the negative 2 because of the filled-in circle, exclude the 1 with the open circle. So include, exclude. And then finally, for that last piece, it's really going from 1, and then it does have the arrow, so it's going to go forever, including the 1, since it has that solid dot, so x will be equal to or greater than 1 for the domain restriction of that, and then that completely defines that piecewise function there for us.